all levers have three common parts. They have what we call a fulcrum, which is the point that the device pivots on or rotates on. There's a place where the load will sit, okay? And there's another location where the effort force is applied. All right, so now, when it comes to classifying objects as being class 1, class 2, or class 3, it comes down to where are these three things located. All right, so I'm just going to quickly run through where you'll find each of these three components in the three classes of levers, and then we'll take a look at some specific examples of levers, and I'll explain why they are the class that they are. So let's start with class 1. All right, so a class 1 lever can take many different forms, but what they all have in common is that the fulcrum, which I'll represent with the triangle, is always located somewhere in the middle. The load, which I'll represent with a box, is going to be on one end, and the effort force, or where you apply your effort force, is at the other end. So, to be a class 1 lever, the fulcrum has to be somewhere, anywhere, in between those other two components. All right? Now, class 2 moves these things around a little bit. The fulcrum in a class 2 lever goes to the end. Okay? The effort force remains on at one end, but in this case you'll notice that you're lifting up as opposed to pushing down, at least in this diagram. And then what's in the middle here is the load. All right, so the load sits in the middle. All right, and then from that, you can probably guess that with a class 3 lever, what's going to be different is that you're going to have the effort force in the middle. So now the fulcrum will remain at the end like it was in a class 2. The load is going to go to the opposite end, and then you're going to apply your effort force somewhere in the middle. All right, so class 1, the fulcrum is in the middle. Class 2, the load is in the middle. Class 3, you have your effort force being applied somewhere in the middle. So now let's start with class 1, and we'll look at a couple of examples. All right, so you had to do a classification sheet, and some of you did really well with that, and some of you still struggle with trying to figure out what things should be. So let's start with scissors. All right, scissors are class 1, okay? Don't be too critical of my artwork here. All right, so this is a pair of scissors. Think about where those three components are. The pivot point is right here, so this is the fulcrum right in the middle. Okay, the load is going to be up here, it's whatever you're cutting, and the effort force is being applied at the other end, where the handles are, where you squeeze them together. So again, you have that arrangement, even though it looks very different, of effort force and load on the outside, fulcrum in the middle. So scissors fall into that category. Pliers would be exactly the same thing. You have the handle of the pliers, you squeeze them together, the nut or whatever you're trying to tighten or loosens at the other end, and then the fulcrum is in the middle. So you could probably think of other tools that would be similar to that. Maybe you have hedge trimmers or something like that. Same idea. All right, so all of those things classify as class 1 levers. Another one would be a hammer. So again, great artwork here. All right, so if this is my hammer, okay, that's actually not too bad. All right, now there's two ways you can use a hammer. You can use a hammer to pound nails in, and we'll talk about that a little bit later. But you can also use a hammer when it's in this position to pull nails. So let's say I've got a nail and a piece of wood here, and I'm trying to pull it out. Okay, the load would be represented by the nail that I'm trying to pull out. So here's my load. I grab the handle up here and I'm going to pull here, so that's the effort force. Well, the hammer is going to pivot right here on this part. Okay, so our fulcrum ends up being here. So now this is exactly the same as this was. You've got effort force, fulcrum, load in that order. It's just that it's bent around a corner. Okay, but it still qualifies as a class 1 for that reason. So scissors, a hammer used this way, pliers, all class 1. All right, now consider class 2. All right, class 2, remember our basic representative diagram for a class 2. The load was in the middle. Now this looks very similar to an everyday tool that some of you may have in your yard, which is a wheelbarrow. All right, so let's say you've got a wheelbarrow here, you've got handles here, you're going to put a load of dirt or whatever in it here. All right, the wheel would represent the fulcrum, you're lifting up on this end, and the load is in the middle. Okay, class 2. So a wheelbarrow is like the perfect example of what a class 2 lever would look like. The load is in between. And now you can move the load closer to the front of the wheelbarrow, or you can move it to the back of the wheelbarrow, and that may change how heavy the load feels, but as long as it's in the middle, it's class 2. Now another example that we saw on the classification sheet that you had was the nutcracker. Okay, and some of you recognize this right away. So here is my rough version of a nutcracker. Okay, not very good. All right, there's a kind of a connection point or a pivot right here. This would represent the fulcrum. You squeeze on the end, and the nut that you're trying to crack goes in the middle. So fulcrum, load, effort force. The load is in the middle. It doesn't look anything like a wheelbarrow, but it's a class 2 lever because of the arrangement of those 3 components. All right, moving on. Let's look at class 3. Okay, class 3 levers. This one can sometimes be a little bit confusing. We have the fulcrum on the end, the load is going to be at the other end, and we apply the effort force somewhere in the middle. Now, there were several examples of class 3 levers on the worksheet. One were the tweezers. Now, think about the tweezers for a minute. Okay, you're squeezing down somewhere in here. Usually your fingers are going to squeeze in the middle. Maybe there's a sliver or a splinter or something you're trying to pick up or pull out. That's going to be down here. That represents the load. And the fulcrum is right here. So fulcrum, load or effort force in the middle, and load at the other end. Class 3. Similar look to nutcrackers, but the difference is where you're squeezing. Here the load is at the end and you squeeze in the middle. With the nutcracker, you squeezed at the end and the nut or the load was in the middle. Now, the majority of class 3 levers sometimes are confused as not being levers at all. And they are things that basically become extensions of your arm. So there were several things on your sheet, like a broom, there was a fishing pole, or a fishing rod. I think there was a shovel. Okay, there's a mention in various places on your assignments of like a canoe paddle or a paddle. To that, I'm going to also add like a baseball bat, a tennis racket, a golf club. All of these things are considered class 3. Now, here's the reason why. So imagine this stick, and I say that this is a lever. Well, you look at it, it doesn't appear to be any fulcrum on it. Where would the load be? Where's the effort force? Okay, so let's just say for a minute that this is a baseball bat. I'm going to turn around here for a minute because I'm left-handed. If this were my baseball bat and I were trying to hit a ball with it, the ball would represent the load. So I'm striking the ball at this end of the bat, so that's where the load is. Now, my effort force, obviously, is where I'm applying the force to the bat. So I'm swinging it here. My effort force is being applied right here. All right. So the only thing that's missing now is the fulcrum. Well, there's no real fulcrum on the baseball bat itself. Where is the fulcrum at? The baseball bat acts as a lever when it becomes an extension of your arms. Okay, so when I'm holding this, load, effort force, the fulcrum is actually further up my arms. It could be in my wrists, okay, if I'm doing this. It could be in my elbows if I'm bending them here. Or it could be in my shoulders or just in my torso as I twist and I turn to take a swing with the bat. Same thing with the broom. The load is at the end of the broom. It's the dirt that I'm pushing across the floor. I'm holding on to the broom here. That's the effort force. And the fulcrum would be further up my arms in my elbows and shoulders. Fishing rod, same thing. Okay, so if I'm casting, okay, the load is at the end, effort force is here, fulcrum is right here in my elbow. So all of these tools actually classify as class 3 because they become extensions of your arm. okay? And the fulcrum is always back in your arm at your elbow joint, your wrist joint, or your shoulders. The effort force is where you're holding on to it, and the load is at the opposite end. Little confusing, but if you look at any tool and you say, hey, it's an extension of my arm, automatically it's going to be a class 3. Now, that being said, really, you could say anything is a class 3 if you pick it up and you swing and hit something with it. If I pick a wheelbarrow up over my head and I start hitting something with a wheelbarrow, then isn't it a class 3? Well, technically, I guess I'm using it as a class 3. But that's not how a wheelbarrow is intended to be used. With its true intention, a wheelbarrow is a class 2. All right? Same thing with scissors. If I'm hitting something with scissors, technically it's class 3, but that's not how scissors are supposed to be used. Now, I said I'd come back to the hammer earlier. Earlier on the example I was showing you that you could pull a nail with a hammer. That made it a class 1. Well, the other use of a hammer is to pound nails. And if you're pounding nails with a hammer, then it becomes a class 3. All right, so we could go either way. All right, so 3 classes of levers, something for you to consider. Hopefully that helps a little bit. If you went through that assignment initially and you made a few mistakes, hopefully this explanation kind of helps you out a little bit. Okay, in the next video, I'm going to talk about mechanical advantage with levers, and we'll go through a few more things. All right, talk to you soon.